Alrighty, so we are going to be talking today about polynomials, the linear factors, and the zeros. So in my opinion, this is the most fun part about polynomials, and I'm so sad that I'm not here to teach this to you guys, but I hope that this video can kind of help you out, and I will be sending this video to you guys through a Remind, so in case you ever want to go back and watch it, that's totally cool. If you don't want to listen to my voice, that's totally fine too. But a couple things we need to know. Multiple zeros. So if a linear factor is repeated in the complete factored form of a polynomial, the zero related to that factor is a multiple zero. So whenever we factor it and we find the zeros, remember that's setting the function equal to 0 and then setting each factor equal to 0. If you have multiple x values that equal the same thing, so let's say that you have x is equal to -1 and x is equal to -1, that's a multiple zero. The multiplicity of the zero is basically how many times does that multiple zero happen. So if this were my multiple zero here of x equals -1, then it has a multiplicity of 2. Okay, that's how many times that zero happens. Okay, then we have relative maximum. Okay, that is your hilltop, an up to down turning point. Okay, and then you have relative minimum, that is your valley. Okay, so keep that in mind. Now I want to come back to this multiplicity thing. So I call this bounce, bounce, cross. Okay, so if we look at a function, and I think on your paper you have y is equal to x squared plus 4x plus 4. So first of all, try and sketch a graph of this in your mind. How many times should this cross the x-axis? Well, the degree will tell you it's twice. Okay, is this going to be an opening upwards or opening down, a rocky or a hulk? Based on your a value, it's going to be a rocky, so it's going to look something like that. Okay, so we can actually graph this based on where the zeros are. So if we set this function equal to 0, and then we factor. Okay, so what two numbers will multiply to give you 4, but add to give you 4? Well, that's 2 and 2. So your factored form is x plus 2 and x plus 2. You set each of those factors equal to 0, and you get x is equal to -2 twice. Okay, so this is what we call a bounce. Because the multiplicity is even, it bounces off the x-axis. So right here is your 0 value. Now based on the equation, where does it intercept the y-axis? What's the y-intercept? It's at 4, so 1, 2, 3, 4 should be right there. And because quadratics are symmetric, I know that over here it's going to be 4 as well. So my graph is going to look like this. Okay, it bounces off the x-axis. That's what that multiplicity does. It tells you how many times is it going to bounce off the x-axis or is it going to cross. Okay, and so if we look at our second one here, you guys should have something like y equals 2x. So if we find the zeros here, well, first of all, what's this graph going to look like? It's a linear function, so it's going to be a straight line. So if we set this equal to 0, okay, divide by 2 to get x by itself, well then 0 equals x. Well, how many times does this 0 happen? Only once. So if it's only once, it is going to cross. So think back to the very beginning. How am I going to graph this? Where's the y-intercept? It's at 0, 0. And what's the slope of this function? Well, it's 2, so you're going to go up 2 over 1. Okay? And you have a graph that looks like that. Because this 0 only happened once, it crossed the x-axis. Okay? So here's something you need to keep in mind. If a 0 happens an even number of times, it bounces. Okay? If a 0 happens an odd number of times, it crosses. Okay? So that's where the multiplicity is going to come in. How many times does that 0 happen? If it's an even number of times, it's going to bounce off the graph. If it's an odd number, it's going to cross. Okay, so keep that in mind as we're going through these notes. Okay, so we're going to talk about, let me get to my slide here. We're going to talk about some different factoring methods. Okay, so the first method we're going to talk about is just using greatest common factor. So what is the factored form of the following? Use the same steps as factoring quadratic functions. So if you look at this first expression here, can you factor out a greatest common factor? Well, yes, you can factor out an x. And what you're left with is x squared minus 2x minus 15. Okay, now can you factor this quadratic? So are there two numbers that will multiply to give you negative 15, but add to give you negative 2? So 3 and negative 5 will work. So keeping this x around, don't lose him. You have x plus 3 and x minus 5. Okay? That is your factored form. That is completely factored. So this is a cubic function. How many times should this cross the x-axis? 3 times. 1, 2, 3. You're going to have 3 zeros. Okay? That's why I've been stressing factoring so much, is because this is where it comes back. Alright, let's look at the next one. For number 2, you actually need some equations. So, in the corner here, if you have a sum of cubes. So if you have perfect cubes, let's say a cubed and plus b cubed, and it's a sum, so it means it's adding, this is how you factor. It's a plus b, and then a squared minus ab plus b squared. Okay, so that's if you add. Here's the difference. So if you have a cubed minus b cubed, it'll be a minus b, a squared plus ab plus b squared. Okay, so this is whenever you need to recognize your perfect cubes. So if you look at number 2, x cubed minus 27. Those are perfect cubes. So your a, in this case, is going to be x. Okay, x cubed is a perfect cube of x. The b, well, what's the perfect cube of 27? That's 3. So because we are subtracting, we are going to be using the difference of cubes. So the factored form is a minus b. So we'll have x minus 3, a squared, which will be x squared, plus a times b, which is 3x, plus b squared, which would be 9. Okay? And 9 times out of 10, you cannot factor that one anymore. Okay? Very, very rarely can you factor that. So that's completely factored. Okay? Now, on the next one, number 3, can you factor out a greatest common factor? Well, yeah. You can factor out a 2x, and you're left with x cubed plus 8. You are not done yet. X cubed plus 8. 8 is a perfect cube. Okay? Now, these are being added, so this is where we're going to use the sum of cubes. Well, x cubed is a perfect cube of what? X. 8 is a perfect cube of what? 2. So I'm going to leave this 2x out front here. Then I'm going to use my formula, a plus b. So I'm going to have x plus 2, a squared, so x squared, plus 2x, and then your b squared, that's where you get the 4. Okay, that is completely factored. So start to learn to recognize these perfect cubes. So 8 is a perfect cube, 27 is a perfect cube. Let me think of what other one. I think 125 is a perfect cube. Okay, start to think about that. So if we look at number 4 gets a little interesting. We have x to the 4th plus x squared minus 5. So this is a trinomial, 3 terms. But this is what I want you to notice. You have x to the 4th straight to x squared. This is a very special kind of factoring. Okay? So what I'm going to do is I call this a substitution. And I'm going to take some a value and I'm going to set it equal to x squared. So what happens if I have a squared? Well, then that's x squared all to the 2nd power, which is x to the 4th. So what I'm going to do is I'm going to substitute these a values in for x here. So x to the 4th, that's a squared, plus 4a minus 5. Okay? Now this looks like a quadratic. We can factor this. Find two numbers that will multiply to negative 5 but add to 4. Well, that's 5 and negative 1. So my factored form is a plus 5 and a minus 1. Once you have the initial factoring done, you can plug in your x squared and x to the 4th into your a's. So remember, a is equal to x squared. So I have x squared plus 5 and x squared minus 1. Now, I hope that there's some bells going off with that guy. Can it be factored more? Well, that is a difference of squares. So x squared plus 5 is going to stay the same. To factor that guy, you have x plus 1 and x minus 1. Now that is factored as far as it'll go. Okay, so this is kind of a neat trick to have, but it only works whenever you have x to the 4th and then x squared. Okay, so if you need to pause the video and try a couple practice problems, maybe talk with each other, make sure everybody's on the same page before we go on. Okay, so let's talk about actually finding the zeros. So in quadratics, there were a couple ways that we could find the zeros. We could use a quadratic formula, We could factor it, and then we could use our graphing calculator. We can use 2 out of the 3 for polynomials. We can factor, and we can use our graphing calculator. The quadratic formula has no place here because we are not dealing with quadratics. We have higher degree polynomials. Okay? Luckily, all of these have been factored for you. You lucky ducks. So, we just go through the steps of finding the zeros. So, everything has to be set equal to 0. So, you'll have 0 is equal to x minus 1 times x plus 2. Remember your zero product property. Set each factor equal to 0. Okay? Then, just solve for x. So x equals 1 and x equals negative 2. These are your zeros. So on your graph here, at x equals 1, you have a 0, and at x equals negative 2. Now, how do you get the rest of this graph? That's where the end behavior comes in. Okay? Think about what does this graph look like? To find the end behavior, in your factored form, multiply all of your first terms together. So x times x, well, that's going to equal x squared. That will be your leading term. So, based on that, what does the end behavior look like? You should recognize that that's a quadratic, and it's going to be up, up. So, at this point, I know that the graph is heading this way in the zeros, and then you just connect the dots. Okay, so you should have a graph that looks something like this. Okay? So that's how you sketch a graph of the function using the zeros. Let's try another one. If we look at number 2. I don't know why this 3 is there. Just scratch that guy out. Find the zeros. So set everything equal to 0. So x plus 2 is going to equal 0. X minus 1 equals 0. And x minus 3 equals 0. So that means that x is equal to negative 2, x is equal to 1, and x is equal to 3. So plot those points on your graph. Negative 2, 1, and 3. So we have the zeros. Now we need to know what the function is doing kind of in between and on the outskirts. Again, end behavior. So multiply all of your first terms together. X times x times x. Well, that's x cubed. So what does the end behavior look like of an x cubed function? If you look at your chart or if you look in the back of the room, you'll realize that that is a down-up end behavior. And I just dropped my pencil. So on the far left-hand side, this function is going to be heading down. On the far right side, this function is going to be going up. And then you just play connect the dots. Okay? I don't have any multiplicities here, so everything crosses through. Okay? Now, this is just a rough sketch. It's not exactly what it's going to look like, but it's pretty close. Okay? Let's do another one. So I have x times x plus 2 times x plus 3. So again, set everything equal to 0. Well, x equals 0, that's done. X equals negative 2, and x equals negative 3. So plot those zeros on your graph. Okay, figure out the end behavior. Multiply all the first terms. What's x times x times x? That's x cubed. What does the end behavior of an x cubed function do? That's a down up. Okay, so on the far left side, this function is going to be going down. On the far right, it's going to be heading up. And just connect the dots. Okay, so I'm hoping that you guys can start to see these functions take shape even before you start graphing them. That's my hope anyways. All right, so you do have a practice problem on this. If you need to pause and work on that, go for it. But I'm going to move on. Writing a polynomial function from its zeros. I think this is pretty cool. So it says, what is a cubic polynomial function in standard form with zeros -2, 2, and 3? So I've already taught you how to find the zeros from the factored form. Now we're going to go backwards. Okay, so based on this information, I know that my zeros are x equals -2, x equals +2, and x equals +3. Well, if you look back here, we had x equals -3, x equals -2, and x equals 0. Well, how did we get those? By setting each factor equal to 0. So in this example, we're going to get each of these equal to 0. So I'm going to have x plus 2 is equal to 0. X minus 2 is equal to 0. And x minus 3 is equal to 0. These are your factors. Okay, so you can smash them all together and create a polynomial function. So I have x plus 2 times x minus 2 times x minus 3. Okay, now it wants it in standard form. Go ahead and put a star by this. I will explain this whenever I get back because it can get quite confusing and I don't want to do that just yet. But you have the factored form right here. So this is your factored form. Okay, let's look at another one. What is the quartic polynomial function in standard form with zeros -2, -2, 2, and 3? Quartic, what degree is that? That should be x to the 4th. Okay, well that means that you have 4 zeros. Hey look, you have 4 zeros. Okay, so you know that x equals -2, x equals -2, x equals +2, and x equals +3. So set all of these equal to 0. So you're going to have x plus 2 equals 0, x plus 2 equals 0, x minus 2 equals 0, and x minus 3 equals 0. These are your factored forms, or your factors. So smash them all together. And you get the factored form of your polynomial. One thing I want you to look at is look here. Those are the same. So I can rewrite this as y equals x plus 2 squared times x minus 2 times x minus 3. I want you to know that this is a multiplicity of 2. So that 0 happens twice. Okay? So if it's an even multiplicity, what is it going to do on the graph? It's going to bounce. So at x equals -2, that should bounce off the graph. So your next problem is to graph both of these functions. Okay? So our first polynomial we had was, let me go back to it, x plus 2, x minus 2, and x minus 3. So the zeros were negative 2, positive 2, and positive 3. Any multiplicities here? No, they all happen once. What does the end behavior look like? So if you multiply all three of those terms, those first terms, you're going to get x cubed. The end behavior is down up. Okay, so on the left hand side it's going to be going down, right hand side is going to be going up, and just connect the dots. Your second function here, oh, you can barely see that color. Let's get a darker blue. Was y is equal to x plus 2 squared times x minus 2 times x minus 3. You can barely see that. Let me see here. Let's see if this is working. There we go. Okay. I'm still getting the hang of this program. X minus 2 and x minus 3. Okay, so this is where the multiplicity happens. It's at negative 2. Okay, so wait, did I have that first one graphed right? Okay. So you have the same zeros, but different end behaviors. Remember this one, you can write this twice. Okay, multiply all of your first terms. What's x times x times x times x? That's x to the 4th, and you should recognize that that's an up end behavior. So here, this graph is going to be going up, going up. Now, pay attention to this multiplicity. It bounces at that point. So whenever x equals negative 2, it's going to bounce, but then it's going to cross all the other ones. Okay, so the only difference between the red and the green is that the green one has a multiplicity at negative 2. Okay, that changes their end behavior. All right, I hope this is making more sense. Let me see, do I have any more? We are going to talk about multiplicity. Okay, so I've kind of already touched on it. Remember, multiplicity is how many times does the 0 happen. If it's an even number of times, it bounces. If it's an odd number, it crosses. So find the 0 of each function and state the multiplicity. So if we factor this, you should recognize that you can factor out a greatest common factor of x squared, and that leaves x squared minus 2x minus 8. Well, that can factor. What are two numbers that will multiply to negative 8 but add to negative 2? So negative 4 and 2. So I have x minus 4 and x plus 2. Okay, set all of this equal to 0. That means that x squared is equal to 0, x minus 4 is equal to 0, and x plus 2 is equal to 0. This is where your multiplicity happens. How many x's do you have there? You technically have x times x, which is equal to 0. So you can set each of them equal to 0. Over here, your 0 is x is equal to 4, and x is equal to negative 2. So, 1, 2, 3, and kind of 4. Okay? But here, This is where you have a multiplicity of 2. So don't forget about that squared. That means something, and it's super important. What is this going to do on the graph? This is going to bounce. Okay, so if I do a rough sketch of the graph, see at -2 I have a 0. At 4 I have a 0. And at 0. Well, based on the leading term here, what's the end behavior? It should be up, up. Okay, so if it crosses here at 0, it's going to bounce. Okay, that's what a rough sketch of that graph is going to look like. And don't freak out, guys. If you are not understanding any of this, I can help you out, okay? I just wanted you to get a little taste of this, okay? 2 more and then we'll call it. So y is equal to x plus 3 quantity cubed. So if you notice, you can rewrite this as x plus 3 times. So I hope you realize that you're going to have a 0 of x equals -3 3 times. So that means that you have a multiplicity of 3. Now, your multiplicity is odd, so what's it going to do on the graph? It's going to cross. Okay? And if you were to graph this super quick, there's your 0. It's a cubic function. So x times x times x is x cubed. That end behavior is down and up. Okay, this one doesn't really have a multiple zeros. Well, it does have multiple zeros, but different zeros. Okay. Let's look at number 3. Last one. So you should recognize, or not recognize, but you should notice that you will have a multiplicity here. This is where the multiplicity is going to happen. And it already tells you how many times it's going to happen. It's going to happen twice. So if we set this equal to 0, I'm going to factor this out and write it twice. Okay, you will notice that you have zeros at x equals -1, -1, +1, and +2. This is your multiplicity. And it's of 2 because it happens twice. What is this going to do on the graph? This is going to bounce. So if I sketch a graph at -1, +1, and +2, what is the end behavior? Multiply all of your first terms. X times x times x times x. That's going to give you x to the 4th, which is going to be an up, up. Okay, so over here it's going up. Over here it's going up. Where does the bounce happen? It happens at -1. So you're going down, it's going to bounce off, and then everywhere else it's going to cross. Okay, again, very rough sketch of what that looks like. Okay, so I hope this hasn't been super boring. I hope that you're getting something out of this. Talk with each other, figure out where people are stuck. I have my phone with me. If you guys need help, you can text me on Remind. But for the rest of the class period, either work on the factoring by grouping worksheet, or you can finish these practice problems, or you can work on missing work. Okay? Let me know if you have any questions.